this. And so I didn't realize they weren't going to have someone looking up my phone. So Nick and I are going to, we're going to present separately, but then we can also do Q&A here if we have available time, and then of course we can talk through on the panel. So, hold on. All right, so what I'm going to do is I'm going to talk about SD-WAN more generally, and then Nick, I will hand off to Nick, and he will go through Hughes's offer as a use case, kind of looking into the inner workings of a deployment strategy. So a little bit of background, oh, I didn't, sorry. Background about me. So I've been, as my bio had said, I've been in the industry for 20 plus years, and I've only ever worked IP. I've only ever worked with routing protocols and MPLS. So I have never done anything else. So essentially, I love routing. I love routing more than anything in the whole world, especially BGP. So the question becomes, why would somebody like me be willing to forfeit, because isn't SD-WAN all about getting rid of routing protocols, all about going to a next generation, and making multi-steering available? Well, the answer is actually no. So SD-WAN, in terms of conceptually and the deployment strategies and standards that have been established, really works with routing protocol concepts. So it's using the idea of policy. So it's doing that, but it's taking it beyond the endpoint, and that's your very standard way of doing routing, is I have 2 endpoints and I need to establish a best path to get there. So what SD-WAN, software-defined WAN, does is it allows you to start thinking about applications and users. So it's no longer about endpoints, it's about applications and users and the mobility they require now, which is the cloud part of this. So we're not going to go through cloud, we're going to focus on SD-WAN components that you should view as important, and either your statement of objective or statement of work, whichever way you pursue the EIS. Structure. So I'm going to go on here. Okay, oh, we got. All right, so an optimal experience for users. Again, it's all about users, and it's all about where those users need to go. So currently, and in most cases for about the past 10 years, those users were sitting in offices, physical offices, and they were going to physical data centers. So that has changed. With the onset of cloud and of mobility for users, the users can be anywhere, and their data might change its location. On a Tuesday morning, it might be in one place, and then Tuesday afternoon at 3:30, it might be in a different place. So it's all about looking at application quality of service. So how many engineers or engineering team members do I have in the room? All right, so we have some. So QoS is typically quality of service, class of service, is typically a standard. You're looking at an IP packet and you've got markings on it. And so what we're saying here with SD-WAN is that is now extended to looking at applications and users collaboration. So I need to have specific things if I'm in a Citrix environment, for example, much different than if I have YouTube streaming, if you allow YouTube streaming, to get through. So those are 2 different things, and so it's not just about making sure they get from A to B, but it's also wrapping them in performance thresholds. Why? Is because you want to give the option to do dynamic path steering, or I'm sorry, dynamic path selection. Again, routing, what does routing do? It's all about stability. The internet was based on stability. I have a best path selection process. That means I have one path. Now you can manipulate that and make it more than one path, but that gets a little difficult. So what SD-WAN does, as Tony had alluded to, is SD-WAN now allows you to incorporate more than one physical and logical link set, so that you can have MPLS, you can have broadband, you can have satellite, and you can have wireless. And you can have all of those in an active-active formation, which again, on some level, breaks my heart, because that destroys everything that routing, classic routing, is about. But what it does is gives you a bundle. It gives you a transport bundle to work with, which is a very new concept. Usually you work active-passive, or you do very, very elaborate configuration manipulation in order to get multiple active-active paths. So this introduces the idea of bundle and not single instances, and that is very helpful for incorporating more bandwidth and cost-effective bandwidth as an active path. And then the last two are packet duplication and for error correction. So these are essentially concepts borrowed from WAN optimization. So I'm not letting go of routing. If you have Riverbed or Silver Peak, you're not letting go in an SD-WAN deployment. You're not letting go of these attributes, which would be to say, if I sense a problem on my network or on that particular path, I can incorporate a duplicate packet so that I can cover being able to have performance metrics that my users need. Again, it's all about the users and it's all about the data. And then packet duplication allows you to send it multiple paths. Again, incorporating the ability, performance criteria is established, if not by the users, certainly by user feedback. And if you provide SLAs to your users, these are the tools that you're going to be able to use to enforce those SLAs. All right, so internet access. So kind of going back, and I can't tell, it says, I'm not sure how much time I have because I know it rolled. So I'm assuming that we have, right now it says 43 minutes. Transforming internet egress. So currently, I mean, this is a federal audience, or an audience focused on federal agencies. And the use of internet, until very recently, you could use IPsec tunnels and you could incorporate that for specific use cases in terms of application support sets. But it was very difficult to do that if you didn't have, your tunnel was point A, it needed to go to point B to terminate, which generally means you went to a data center. So you have essentially a centralized, does it have a pointer? Oh no, it doesn't have a pointer. A centralized environment. And so to get to, for example, in this example, to get to Office 365, if you use the internet, typically what would be required is your user had an IPsec tunnel at his endpoint. He came back to the data center, he decrypted, and then that had a path to Office 365. So if that user's in San Francisco and your data center, because you're a federal agency, happens to be in Washington, D.C., and the Office 365 is in Chicago, that is a performance detriment to your user. So the alternatives are to use a hybrid or a decentralized environment. And that allows you still to keep the encryption, but it allows you to terminate the tunnel equivalent based on where the application needs to go. So in this case, what we're saying is at a site in San Francisco, if it needs to go to Office 365, then I would allow, based on a firewall policy locally on that, and a forwarding attribute that Office 365 requires, which is, let's say, when this is your application set, primary application set, it's pretty rigorous in terms of what it needs. So I need to maintain very high threshold standards in my threshold set. But they can go now to Office 365 directly. So how is that possible? Is that so Microsoft and Amazon and Google are incorporating SD-WAN, essentially endpoints, into their deployment strategy, so into their marketplaces as well. So that allows your user in San Francisco to go to 11 Great Oaks in San Jose for their Office 365 consumption. That's much better than San Francisco to DC back to Chicago. So that's very helpful. And then decentralized is to say, in certain cases, based on the agency and your mission, it may be permissible that all traffic goes directly from a site, including raw internet traffic, and that would provide optimal performance. So in the old world, essentially, you have to configure routers. So the internet, and then successor wide area networking were based on endpoints, and you have to go in and you have to configure routers. Now you can do that in a very detailed way, but you still have to configure them individually, and what it produces is it produces an environment where that endpoint, that's its worldview. It makes the endpoint makes all its decisions for itself. There's no top of the hierarchy. And again, going back to the internet and how the internet was built, it's all based on peering, right? And that's how MPLS and other WAN technologies evolved, is endpoints have their own worldview, and I don't have a top of the stack hierarchy. So in this case, it makes you, in this case, it makes application configurations, appliance configurations on an individual basis. Well, an alternative with SD-WAN is to say, if I introduce a centralized hierarchical entity, say a controller, something that has a world view, then I can start to view, and I'm so sorry I don't have a pointer, appliance configurations as a single universal instance. And that would allow me to configure base structures universally, not going into any individual router, and deploy those all at once. And also to make changes all at once. And so in here in a branch template, these are the things what kind of transport do I have, what QoS parameters do I need, and then you just simply are able to push it out. This is the concept I'm sure you heard of, zero-touch provisioning and optimized deployment, application deployment updates. So in this case, these are only variations that I really have in my branch template, is what kind of bandwidth, how many pieces of bandwidth do I have, and how do they fit together. So if I take this information where I know what I need to deploy, I know what the branch has specifically, now we can introduce a universal template deployment strategy, which helps your staff not have to touch individual routers, either for new deployments or for putting in updated scenarios. For example, if you decide in March, and how many, do I have cloud team members here? Okay, so if your cloud team doesn't tell you they've moved a workload on a Wednesday, and all of a sudden that workload is 1,500 miles away from where it was in the morning, which happens a lot because cloud teams don't really care about bandwidth, they care about applications. That allows you in real time to be able to go into that template and push a new policy set down to all your users. So in that case, if the cloud provider or the cloud team didn't tell you, you might have to suffer through 30 minutes of outrageously angry calls from users, but it's only 30 minutes. If you had to go in and touch every router, that's 3 weeks. So this is what you gain a transformative element along with a transition component. All right, and I think, all right, so network functions. Again, I said I loved routing, and I do love routing. Sometimes I bore people with talking about routing. Hopefully I won't do that to you today. But so routing, this is where you are. This is where the typical agency is. They have routing and routing protocols, and that's what their WAN looks like. So it's not fair for us as a provider, sorry, I keep doing that, us as a provider to come in and say, okay, now you need to move to SD-WAN. Period. I'm going to deploy all new services. You buy your EI or finalize your EIS contract, and we give you 90 days, and you need to deploy. That's not going to happen. That's not realistic. That's not fair, and it's not necessary. So, but this is important to know that an SD-WAN strategy from any vendor, and we're one of 9, needs to incorporate what are now considered, sadly, legacy techniques, because you have to transition. You have to start somewhere. But it also needs to involve SD-WAN components. This is whether or not you're going to deploy, let's say you do an EIS and you do transition only, and you go EIS end of 2018, right? And you're in a new contract, but you don't want to deploy SD-WAN until 2020. You still need to have whatever vendor or, and Nick will talk about this more in depth, whatever vendor or appliance set or construct that you have needs to incorporate the future-looking SD-WAN components. And that's going to be dynamic tunnel management. We don't need to have you put in 47 VPN tunnel concentrators and different data centers. That becomes the job of the service provider to provide the mechanism for the dynamic tunnel overlay. You want encryption, right? So you need a tunnel sequence to do that. You want a BGP overlay routing because I win. Because you keep routing is still necessary even in an SD-WAN deployment. And the dynamic path selection multi-point becomes very important. And then of course, the FEC and packet duplication along with packet stripping, those are optimization, WAN optimization techniques to ensure even if you have a broadband or even if you have wireless and you have lower performing instances of that, you still have mechanisms in an SD-WAN portfolio to take care of those temporarily. And those should be part of the SD-WAN deployment, whether you use them day one or you use them 36 months out. Security, again, going back to that model, whether you do distributed internet access, a hybrid, or centralized, you need to have the opportunity to put a template-based security stack locally. So that becomes an important function to assess in an SD-WAN provider's deployment strategy. And then optimization, this is where we go. So all of these, for us, these are roadmaps, and this is, again, trying to provide multiple vendors to do these things. And this allows, again, TCP optimization. Anyone in the room who has worked with WAN optimization knows these are not new terms. It's what they're being used for is new. So I'm in a multi-path environment, and I want to utilize 6 different kind of bandwidth from 6 different vendors. Then I have an additional toolkit to be able to do that well. And that must include analytics, right? Part of transitioning means I need to know what I have in place. So an SD-WAN kind of micro deployment can help you with that. It can establish much richer analytics because, again, you're dealing with applications now. Analytics can really tell you about behavior in the network before you choose to buy 6 different kinds of bandwidth. So very helpful. All right, and these are just a general overview. We can, you want your provider, in our case we do, we can offer just a basic. So if you're centralized and you don't need firewall operations locally, you can do that all the way up to having advanced security, including DDoS detection, which is gonna say my endpoint is visible. And my endpoint needs to be protected against a random bandwidth consuming kind of network killing attack. So those are things that are important as well. And so we talked a little bit about controllers, or I had talked a little bit about controllers. Again, that hierarchical element at the top, which the internet doesn't have, and standard MPLS, other than route reflectors, MPLS doesn't have either. And so this is the real component you're introducing here. You're introducing with portals and controllers a worldview. Because I need a worldview to assess what my users want, what their applications need, and how to interconnect those two things. So this is basically your blueprint. I have branch users and I have data centers, and I have a worldview. What can I accomplish with this that is both transition ready and transformative at will? And I have to make sure I don't go too fast with the animation because that kills it, sorry. All right, so essentially I need a device. So you decide on the device, and that device in the SD-WAN environment, and Nick will talk about their deployment. There are many devices that are capable of doing all the things we've discussed. But you need to assess initially if it can do exactly what it's doing now, and then given the timeline your agency needs, how quickly can it deploy all the functions we've talked about. So that becomes very important, the device. Then MPLS, whether or not you want to retain MPLS. You can do that. Some things like voice over IP really like, I like MPLS, but voice over IP likes MPLS even more. But given budgets and given the ability to do some of the WAN optimization I discussed, maybe you don't have MPLS. Or maybe you add all of these functions. So I have a bundle of 6 transports, right? And those should be available, and I add into that a firewall mix and a toolkit so that I can look at analytics and decide whether or not maybe I don't need wireless because it never gets used. Or maybe the DSL really, because it has very strict asymmetry. You can have as much as you want coming down, but there's never a whole lot going up in terms of bandwidth. Maybe that doesn't make sense. And you can see that from an analytics standpoint. So it's no longer, if you're going to log, read the logs. No, this is portal-based, GUI retrievable analytic structures, which will allow your teams to assess, okay, did I put it in right? Do I need to grow it? How do I need to grow it? Based on the users and based on the applications they're retrieving. So this is an example. If I have a branch appointment, I have voice. Again, voice really likes MPLS. It does not require MPLS. It's very important. And then I'm sending my business applications over both, and it's hard to see that one of the other traffic is brown, and the top one is red. So business applications are going over both. So they're both going over MPLS and internet. But, I'm sorry, here we go. But if I have a cut, I can revert all traffic to the internet. And we've been able to do that for 20 years. So that's no big deal. But what happens now, if I have a cut here, or not cut, if I have a degraded circuit, what happens if I have the kids come home from school and my cable access is essentially unusable for 4 hours? How do I deal with that? And you're looking at a network that can auto-sense the degradation has come or has hit a threshold under which it's not allowed to use the internet anymore. So it continues to move everything over to the MPLS for that period of time, after which it's restored, and not physically restored. It was never down, it was degraded. It can now be restored to that component. And so these are the things from a service provider. I'm running slow on time here. A service provider and an SD-WAN deployment, regardless whether it's us or Hughes as an extension of CenturyLink, or Hughes alone, or any other vendor providing an SD-WAN deployment strategy offering a service. You want to, again, have routing. And it goes back because it's all about me, but you need routing. You need basic things because you need to be able to transition on your agency's own terms. That's super, super important. You also need the security, whether you use it or not. The box and the provider need to be able to support the security functions that you need today or during your initial transition, but also with cloud, the movement to cloud, you may not know in 2 years what kind of security requirements exist, and you don't want to be in a position where you have to redeploy equipment. That's hugely important. Then operations, the ability for you to self-provision. So going back to that template and doing either a zero-touch provisioning where the branch site, if you install a new branch site, it so-called calls home, gets its configuration and pushes it down. Or whether you want to be able to do a co-management. And again, EIS is very flexible on this. Perhaps you want to have some control of the controller or some insight into the controller past read-only. And that becomes important if you want to start building, for example, new cloud strategies or new onloads with interagency. That becomes very important because that's a very nuanced kind of deployment set. The portal, this needs to hold your configurations and your analytics, and it needs to work as well as your iPhone. So it needs to look exactly like your iPhone looks in terms of ease of use, not having to call in or struggle with the interface. And then transport. You need a provider, and this is, I'll hand it over to Nick here in a moment here. You need a provider that can extend past their own reach. So CenturyLink, for example, doesn't have wireless service. Even with our incorporation of level 3, we don't offer wireless service. That is a choice we've made in terms of a strategy. We're a transport provider, and we are able to lease that or do a sub for that. The same thing with satellite. We don't offer satellite service ourselves, but we can reach out to companies like Hughes to incorporate that into. So the provider needs to be able to be transport neutral. They can't only sell or offer what they themselves have or is high margin for them. And that's very important too, because you want to move, again, as we had mentioned, to an active-active transport bundle, so your users and the applications they use can seamlessly move over any type of service you install. So I think that's all I have for, but any questions that come up, we can talk about it on the panel. And I know there are probably a lot of technical sessions. But again, SD-WAN is just a modernization of IP and MPLS. MPLS was a modernization of IP, and SD-WAN takes MPLS one step further. So a very, very logical progression in technology. All right, thank you.
Hello? Okay, good. Just want to make sure. All right, good morning, everybody. My name is Nick Koval, and thank you for the introduction to everybody that preceded me. I'm a senior network architect at Hughes in our business development group, and I'm here to talk to you today about a couple of things. First, I'm going to set the stage for Hughes's history in broadband innovation. Then I'm going to go through some of the challenges that broadband presents to organizations such as yourselves that have to use the internet for business connectivity. Then I'll explain how our services and technology help overcome those challenges to meet your needs. And then we'll tie it all together with how our technology and services will work in CenturyLink's portfolio together as a cohesive solution to meet your needs for the future. So just a few recent accolades that Hughes has collected recently that I just want to bring your attention to help strengthen our position in the market. We have been selected as Fortinet's Global Partner of the Year. This is very important to us. They're a strategic partner in our solution that allows us to bring industry-leading security with our SD-WAN broadband optimization technologies. TMC Net presented us with an SD-WAN Leadership Award at the SD-WAN Expo earlier this year. And there's a few other independent articles that Network World and Global Data did that kind of highlight how our services and solutions are unique to the industry. So the evolution of Hughes broadband innovation actually goes back over 10 years. So we've been doing this technology, and we've been focused in this area for a lot longer than a lot of the SD-WAN startups have been around in the market today. Probably more than twice as long as some of them have been around. So the problem we originally set out to solve was to deliver business class voice over IP over DSL. And back in the day, DSL only had like 1.5 meg up and a couple 100K down. So that was a big challenge by trying to squeeze a lot of applications into one tiny circuit, but ensure that in these variable connections that your mission critical voice over IP traffic could get through and provide a consistent experience. So over the past 10 years, we've developed 4 different technologies that focus on broadband optimization. These are the Hughes active technologies, and I'll explain them in detail in a little bit. But I just want to emphasize that these technologies have been in existence for many years, and we have just recently evolved our solution set to incorporate active path, for example, that really enables us to use multiple paths in an active environment to stitch all of these broadband optimization and security technologies together. So a question. So in the context of broadband internet, how many providers do you think are in the US that can provide these different types of capabilities? I need some answers. Who's got? Tony, I know you know the answer. More than one. More than one. 300 I hear. A little higher. Keep going. 500. Higher. 1,000. Getting closer. So it's actually 2,715. So you can imagine that if you have a choice of buying connectivity for a global, a nationwide network, and you might have to choose between 2,700 providers, that could be a little complex. And that's one of the major problems that we help solve for our customers. So what does that mean? So why is broadband so complex? Why does it have these challenges? It's just a connection to the internet, right? Well, it's definitely different than the connection technology that we're all familiar with, the T1 and MPLS connectivity of the past. It's very dependable. We know exactly what we're going to get when we order a 1.5 meg T1. With broadband, that's not the case. So broadband, if you look at the graph on the left here of the US, this is some Akamai data that shows how the broadband speeds, the available broadband speeds, the average available broadband speeds vary widely depending on where you are in the US. And this graph only goes to state granularity, but you can imagine that even within a state, the variability is even farther, because the access to speeds in broadband depends on whether you're rural or you're urban, whether you're in a metro area, whether you're not, whether you have access to fiber or whether you don't. We all know fiber has much higher speeds, and those aren't available in a lot of rural locations where you might have field offices. So the use of this technology presents a unique set of geographical dependent challenges that are being shown here. The graph on the right is an example of some of the analytical data that we can collect from our technology from a 1,600 site network that has broadband deployed. And what this shows is how many sites, the blue bars represent a day, and how many sites in that network were impacted by a broadband brownout. And a brownout is an indication of a degraded condition where your applications are impacted. It doesn't necessarily mean that your connection's down, but there's something going flaky with the circuit, and my users are going to be unhappy, my applications aren't working. So you can see that the amount of sites that are impacted varies greatly even by the day. And if you look in the bottom right, this is showing that this particular customer, in order to provide broadband access to these 1,600 locations, had to go through 100 suppliers. And that's what Hughes provides and manages on behalf of our customers for them. So the amount of suppliers you need is definitely highly dependent on how geographically diverse you are. The more diverse you are, the more suppliers you'll need. This particular slide highlights the depth and breadth of our access portfolio. And you can see right on top is CenturyLink that provides a key set of capabilities for connectivity that complements our solution as well. And what we have in our portfolio is many other partners that can help us fill in the reaches where CenturyLink can't help us, for example. We also have our satellite technology, that's our heritage that we've been doing for over 40 years. And you can see that by looking at the numbers across the bottom, this indicates where the growth and where the declining in demand. This is based on Hughes customer demand information. So as you would expect, year over year, there's much more demand for cable and fiber access services, and there's a decreasing demand for T1 and DSL. So we just talked about a bunch of the challenges that broadband presents to us. And now I want to talk a little bit about how Hughes helps solve those challenges through some of the benefits that our technology present here, that bring to the table. So one of the things that's key to any SD-WAN solution is the ability to offer these services over any type of transport. And as you can see from the previous slide, we have a plethora of access partners that can provide different types of connectivity, and our solutions and our platforms work on all of these transports. And that's critical so that you can get the right service at the right location. Intelligent Path Control is the ability to actively use multiple connections at any individual location in an intelligent manner. And this means we know that broadband presents a unique set of challenges for availability, variability, and by mixing multiple broadband connections together, you can greatly improve your reachability to your field offices and greatly improve your user experience. And in some cases, you can actually do that much better than you can with an individual MPLS connection, because you can complement large amounts of bandwidth with wide variety of diversity. Next, I want to highlight how network agility is attained through our technologies. So what we do is we have a set of broadband optimization techniques and technology that I'll talk about in a minute. But as I go through them, I want you to just keep an eye on how we focus on automation. And through zero-touch configuration, we have developed each one of these technologies to focus on reducing the amount of configuration that network operators have to put into the system to make it work. Fundamentally, we took a slightly different approach when we developed these technologies. As opposed to making it very easy for an operator to build complex rules through a web interface, we've actually focused on automation technologies that remove the dependencies on operators from actually configuring the network. And so we call that zero-touch configuration. So WAN optimization is key in order to provide that consistent user experience. As Sean was describing earlier, we're now focused on connecting users that are using applications, users to applications. And our users are existing in a wide variety of locations, and the applications are diverse. They are existing in the cloud, and they're existing in our data centers. So it's important to know that when we can only get a DSL connection at our field office, that we can use some WAN optimization technologies to ensure that our mission-critical applications actually feel the same to the end users, whether they're on a DSL or a 30 meg or 50 meg or 100 meg fiber connection. And through WAN optimization, we can actually achieve that. And through automation, we can make that seamless to our operations teams. And finally, secure connectivity is at the core of any SD-WAN solution, because fundamentally we are now using the internet to connect our businesses with. And we know that that comes with a very high focus on security. And through our partnership with Fortinet, we bring this industry-leading security capabilities into the mix of broadband optimization so that we can use that as an access technology to transform our digital businesses. So let's talk a little bit about the platform. So Hughes' SD-WAN platform that we delivered through managed services is a desktop form factor, fanless, 10-port Ethernet switch on the back. It's very compact, it's very economically priced, low cost, and very suitable for very small or medium-sized branch or field office locations. And so the platform itself has a combination of the Hughes developed broadband optimization software and Fortinet's security software. So now I'm just going to talk a little bit about the individual technologies that exist in the Hughes broadband optimization software and the Fortinet software. So I mentioned earlier, these are the four technologies, the active technologies that Hughes has developed over the past 10 years that have put us in this position to be a leader in the broadband optimization space. At the core of this is Active QoS. Active QoS is that technology I mentioned earlier that allows us to give high quality voice experience on a DSL connection, regardless of how many other applications I have running over that. So this is the ability to deliver real-time quality service and flow control, knowing that we can measure our bandwidth and adjust our QoS settings up to 4 times a second. And when broadband varies, has a lot of variability, we know that we can react in real time to always make sure that we can slow down the lower priority traffic, because that's fundamentally what QoS is all about. When I have a mission critical application, I just want to send that through, but the QoS technology has to recognize that I don't have enough room to fit the lower priority applications. So that's what Active QoS focuses on. How to make sure that I can flow control those low priority apps so that my mission critical applications can get through. Active compression adds virtual bandwidth where you might need at those locations that you can't get as much bandwidth as you would like. And we do that through a combination of different multi-stage compression algorithms and caching to add up to 30 times more bandwidth depending on what type of application flow you have. Active Classifier is another very unique technology to the industry, and this doesn't exist anywhere else in the market today. So what we do, we've taken a little bit different approach, and as I mentioned earlier, we focused on automation. So in order to identify applications and then prioritize them, so identify a voice application and put it in a queue, identify an email application and put it in a queue, we do that based on how the application behaves on the network. So this is using heuristic algorithms. This does not require our software to rip apart the packets and look inside and what's going on. If you think about it, if I have any network engineers in the audience, have you ever looked at a Wireshark trace? You know that a voice application looks distinctly on the wire different from an email application. And that looks different from a web browsing application. So by looking at the size of the packets and the frequency of them, we can identify applications and automatically classify them and prioritize them without having to know in advance what applications run the network. This is a huge savings for operation teams because now you can actually deploy new applications to the field without pre-configuring the network for what applications you have to deploy. Knowing that for your sites that have congestion, where you have not as much bandwidth as you need, the technology will take care of that for you. Finally, Active Path is what brings all of the other active technologies together into a cohesive multi-path solution. So while Active QoS and Active Classifier and Active Compression will operate on the individual links, Active Path brings it all together by ensuring you can use multiple paths to inherit the quality, the user experience, the best quality for the best performing individual link there. Now, with the broadband optimization, we also have this capability, the security capability on the same platform. So this is all brought together by Fortinet's FortiGuard subscription services. So this is the ability to leverage global threat presence and threat intelligence that Fortinet can gather for us through their large network of analysts and their large network of endpoints that collect data that are seeing this traffic presiding over the internet at all times throughout the day. And so we can gather, they provide a feed for us to push all the way down to the field office into these platforms that can react and change how an individual site behaves to emerging threats that might be occurring in another part of the world. And this allows subscription services where we might have to use signature type technologies like antivirus that can identify what a bad file looks like. And also where you might have IDS and IPS needs. So this is the ability to identify an attack or a threat on an application server or a web server or a database server. And some of these might even be operating inside the branch. So we have the ability to use the FortiGuard services to detect these types of capabilities through these automated delivery of signatures. Web filtering is the example for where you have to provide internet access to either guests or employees that are at your field office site. And sometimes it's complex to try to restrict that, but you want to be able to say, I want to allow access to news sites, but not access to social media, for example. So you can control your access based on risk and limit the amount of capacity that they're using based on streaming content. And finally, app control is the ability to get a granular list of applications that you might want to apply policy to. So there's over 5,000 applications that Fortinet's FortiGuard security services can actually identify. So I just want to take a little bit of time here and show you and show how the different active technologies work together. So we have these 4 different technologies, and we're showing here 2 different WAN links, and on each WAN link we have 3 priority queues. Now in practice we actually have 10 queues, but for demonstration purposes we're just going to show 3 to make it easy. So you got your typical PC that's on the LAN, and we're going to bring some packets that come out of that going towards the WAN, and in this particular case each of those individual balls represent a packet. And the different colors represent applications because applications are fundamentally comprised of a bunch of different packets. And so Active Path will look at this pile of packets coming off the LAN, and it will break it up into a set that has to be distributed across different paths based on the policy we've created for this. And some applications, such as the green packets here, representing mission-critical application such as voice, that we know needs to go over both paths at the same time. So we'll pass these packets on to Active Classifier. Active Classifier will break them up into the different priority queues based on how the application is behaving across the wire. Again, this is not needing to do DPI or deep packet inspection to rip apart the packets. So this works with encrypted applications. So this works whether the application is encrypted or it's natively unencrypted. And in the world of cloud connectivity, more and more applications are becoming encrypted every day. So this allows us to look at how the applications behave and assign them to the different priority queues without having to build rules to even tell the system what applications need to go where. Next, we'll pass on those individual packets to active compression. It will squeeze them down so that we can best fit them across the WAN based on their individual content and behavior. And then active compression will pass it on to active QoS so that the individual packets will be lined up in an orderly fashion to be sent out over the WAN in the order that best suits the use of that WAN to mitigate the congestion. So high priority applications such as voice will go out first, and you'll see they'll get sent out across both paths at the same time, while the lower priority applications will be flow controlled. And this, again, is the key to delivering a consistent user experience and delivering effective QoS is by slowing down those applications that might potentially impact your high priority applications. So I'm going to go and spend a little bit more time going into some of the capabilities of our individual active technologies. So active QoS, this particular graph that you're looking at here shows bandwidth utilization of a cable site over time. So we ordered a 16 meg circuit, 16 meg down, 2 meg up. But what happened in reality is that the provider, and this is common in the cable space, is actually delivering upwards of 22 megabits per second. And so because our technology can automatically measure and adjust to the available capacity in real time, we can take advantage of that extra capacity when it's available. And when it dips down, you'll see there's a period where it dipped down to 8 megabits. Now, if you had to manually configure your QoS, you typically undersubscribe it. On a 16 meg link, you might send it to 14 meg or 12 meg. But when your available capacity dips below that, you have a problem. You can no longer effectively provide quality of service. So our active QoS will automatically detect that, slow down the flow control of the rate of traffic going out over the WAN, and make room for those critical applications that you need to still get through. So we can, again, focus on delivering a consistent user experience for those mission-critical applications. Now, keep in mind that most of the SD-WAN solutions today on the market require a peered endpoint on the other end to identify and implement this intelligence. And that's true of the Hughes solution as well, and we typically deploy this endpoint inside a customer data center or a partner data center or our data center, depending on your service delivery model and your preference. Well, we can also deliver QoS directly to the cloud. So what that means is that while you deploy your endpoint inside a centralized data center that you control and operate, we can also deliver those 10 levels of priority to the cloud for applications that go directly from the field office, for example, and go directly out over the internet without having a gateway in the cloud. This helps greatly reduce cost while still being able to deliver quality of service to those cloud applications without having presence in all the different public cloud providers. So this is a key differentiator for us for the ability to effectively deliver that QoS both to the cloud and to the data center and have them coexist. And in this particular case, when you have this scenario, which is pretty common, especially when you're going through a transformational phase, applications might move from the prem to the cloud or from your data center to the cloud, and you still want to be able to provide that consistent experience and provide that QoS policy. So this eases the ability to do the transition from premise-based to cloud-based without having to deploy additional gateway resources inside cloud POPs, for example. So active classifier combined with active QoS, this particular graph here is showing quality of voice scores, of VoIP calls. And so there's this there's this measurement called MOS, mean opinion score, that measures the quality of a voice call. And so higher value is good, lower value is bad. And so you can see on the left where we have a congested broadband circuit that under duress, when the WAN has to deal with a congestion of high priority and low priority applications and there's no QoS, the quality of the calls suffer. And what that means is that the people on the other end of the phone can't hear what the other user on the other side is saying. So when we turn on active QoS and active classifier, two major things happen. Before, we couldn't deliver a consistent experience. The range of quality ranged from good to bad. But now you see in the green bars that the experience is consistent. It's very high quality because active classifier automatically identified voice over IP. We didn't have to configure the system to tell it voice was going to be deployed or turned on. It identified it and it automatically prioritized it. So it identified the voice over IP traffic and then recognized that it needs to be put in that high priority queue so that it's not flow controlled and the other applications are. And that's fundamentally how you can deliver a better user experience with these types of technologies. So active compression will add virtual bandwidth to the sites where you have content that can be cached or compressed. So there's a 4-stage algorithm that our platform uses, and it's intelligent and dynamic to the fact that if there's a high amount of throughput and it's requiring a large amount of resources to compress data that's non-compressible, for example, an encrypted application or an encrypted document, we can actually turn that compression off automatically. Again, focusing on automation and not requiring the operators to tell the network what applications are encrypted and which ones aren't. That's automatically done here. So if we can detect that if we're trying to compress something and it's ineffective, we just turn it off. And we have 3 stages of compression depending on the type of content that's being presented to the network. We can do bit level encryption or compression, so that the first time we see a file move across the network, at the individual packet level, we can compress that. So like a Word document that has a lot of repetitive words in it. But also the second time a large object comes across the WAN or a second user might download that file, we can actually pull that whole file out of the cache and save a lot more bandwidth. And so you can see by looking at the graph here that you can turn a 5 meg down circuit, in reality upwards to a 9 meg circuit. So there's a lot of benefit to be had here for those sites that are bandwidth constrained or that you can't deliver the amount of capacity that you would like to based on the broadband regional constraints. And so finally, active path, we have a capability coming here in the near future that will allow us to design some path preference. It's a path preference technology that allows us to use business level rule sets based on performance contracts for applications that allow us to say which application goes where. So you've heard me talk about the different active technologies that don't require configuration for individual paths, for example. And so we might be able to do that. And that's not that big of a problem on individual links. But now when I have multiple links, at some point I need to take some input from a human that might have active knowledge of the business requirements of different applications to say this application such as Dropbox or Office 365 might be best put on my higher bandwidth, more variable internet connection. But my voice over IP and my payment applications, they must reside on my highest availability MPLS circuit. And so that's what this capability allows us to do. So in partnership with CenturyLink, we can combine their access for MPLS with our broadband access and put this into a single solution for you that allows you to drive your business application requirements across a hybrid SD-WAN network. And finally, to bring all this together into a single portal, we have a performance management dashboard that stresses the importance of analytics, as Sean was talking about earlier. This particular snapshot here is an entire network. So from this particular snapshot, you can have a network operator, an IT leader look at and know where to start finding that needle in the haystack. Now, while we certainly have individual site metrics, so you can go down to a site and look at your field office operations and see how bandwidth utilization is going over time, this really allows an operations team to know where to go start working on problems. This is allowing them to be proactive. So this compares sites to each other. So when you have 1,000 sites, you can now know that even though you're not getting any calls from the field, there's 10% of my sites that are underperforming compared to the rest of them. I should probably focus on those particular sites. And this dashboard allows you to drill down to do that. And for example, this allows you to get some insight into some metrics or health metrics that our technologies expose that aren't available elsewhere, such as congestion. So you know what sites are actually experiencing saturation, what sites that you might need to order more bandwidth for. So this allows you to be more proactive on your provisioning side. You might need to scale bandwidth up. This particular type of view into the network allows you to proactively do that based on how your usage and your congestion is trending up or down over time. And with that, I just want to thank you for your time. Looking forward to interacting with you after our session here. I think our panel's coming up next. Feel free to reach out to me on social media. I'm looking forward to having more conversations with all of you. Thank you.